Good morning, everyone. I hope you guys had a good Labor weekend, and we go back. Any questions before I start myself? If you have any, please. I know that you don't have any assignment due, but if you can, in case you have any questions, please put them on the chat. Okay. Before we start, I'd like to make one note about the quiz. The only problem that, each student has different problems, but one question that some students had difficulty with is the following. It was number 3 on the quiz. And the question was to solve the following equation. I'll talk about it for a few minutes and then we go back. So first, how to do it, the best way to do it, and then the mistake that some of you ran into. So first, it's crucial, and I wrote a feedback to a lot of the students, you have to use the property of the natural logarithm correctly. So one of the property of the natural log minus ln of b. So the first thing we're going to isolate the log term somehow. So in this case, isolating means we need to combine them, okay? Okay, I hope this is better. So how do we combine this? We combine them like that. This is ln of A minus the ln of B. This will give me the ln of x plus 1 over x plus 1 over x minus 1. So once it is in this format, and then we say, okay, then e to the ln of the first equal e to power 2. It means this over that. Now the property, another property of the log. As I said, e to the ln of anything, so anything, so I'm gonna put a box to tell you it's anything, is the anything back, because that's the definition of the log. It's the power of e that gives me what's in here. This will give me x plus 1 over x minus 1 equal e squared. Okay. Now it's a matter of solving for x. All right, so we multiply by x minus 1, so we get rid somehow of this denominator, or we cross multiply, whatever you want to call it. You get that. And now we need to isolate the x. So x is a power 1, so it's rather a simple problem. So this is again where we had some difficulties. So it's e squared times x minus e squared. And I need to solve for x. It means I need to have x equal a certain number, something to be very specific. And this way, so I'm going to put all the x's together and everything that had a constant term together. E squared is a constant term, and this is a constant term, okay? Now I need to isolate x. Because I have e squared, the best way to isolate it, because I don't want it to use decimal, I wanted to get used to working with e because it's more exact, basically. Now I isolate my x by factoring it out. And this will finally give me my x, which is minus e squared minus 1 over minus e squared. Okay, so that's really how to solve it. Now, before I move on, I will show you the kind of mistake I saw, so that's the correct process. And now I will show you a little bit the mistake I saw, and let me see what happened. So some student took ln of x plus 1, and I have to address their mistake equal to, okay? And somehow they knew that we have to bring e to the picture. So we get rid of ln. So the student went and wrote something along those lines. And I tell you what the student had in their mind. They put x plus 1 minus something along those lines equal e squared. Okay, so what did the student do, and what's the mistake that the student is doing? The mistake is the following, unless anybody wants to point out. What's the mistake going on here? When I take the e, we have to be very sure. If I say, I'll use numbers. Suppose I have 3 minus 1 equal to 2. That's a correct statement. I'm trying to use numbers to explain the idea here. It means what I am saying is that then if you take e to the power 3 minus 1, that's e squared. It means that's correct. Now, what the student did was the following. The student, when you want to hear what the student had, is e to the 3 minus e to the, I think, yeah, minus e to the 1 is equal to 2. Is this step equal e squared? This step is not correct. If 3 minus 1 equal to 2, it means e to this power equal e to this power. It's not e squared minus e to the minus 1, because if you take e to the a minus b, is not e to the a minus e to the b. We cannot break this. E to the a minus b is e to the a over e to the b. So when a student did the e, what it should be the correct version is the following. E, I mean, you don't have to do that. You already said exactly how to do it. So you have to take e to this whole term equal e squared. So if a student forget to isolate the ln by combining and wants to use the e at this stage, it should be e to this power equal to e squared. Now, if the student did that, and then e to the a minus b is e to the a over e to the b. So we have to use our rules correctly, or the algebra collapses. And then it will become x plus 1, because e to the ln over x minus 1 equal e squared. So I hope those who did this mistake, which is actually a fair number of you, understand. So you cannot say e to ln minus e. This is algebraically wrong. It's e to the power this whole term equal e to the power that, because those two terms are equal to one another. Okay. And please, when I'm grading your quizzes, I do give you feedback. Please read the feedback, and if you don't understand them, let me know. But don't let them slide by, because you will do the mistakes again. Very good. So, any questions before I move on? Right. So today we're going to finalize trigonometry. As I said, I will do what I think I need in the course, and I will not do all the trigonometry you've seen, because you spent like 2 months or so doing trigonometry. So I will do the trigonometry that we need, and then we move on to chapter 2, maybe today or tomorrow at the latest. So last time we did the angle measurement, if you remember, and all of you knew that we have 2 different angle measurements. We have the degree and we have the radian. Degree is basically an arbitrary unit, and the radian is based on a definite meaning. The radian is the following. You start with the unit circle. It means circle of radius 1. You take an arc of length 1. And the angle at the center, this is 1 radian. And the main conversion between degree and radian, pi is 180 degrees. 1 degree is very little. It's pi over 180. And 1 radian is 180 over pi, which is almost 57 degrees. So it's nice to know how much is the radian. Now, sine and cosine. We'll start with the first definition of sine and cosine, that is called the right angle definition, which is not the one that you will be using. So let us recall the right angle definition of sine and cosine. Okay, the right angle, the one that you first learn when you learn sine and cosine. So this basically based on, you start with a triangle and right triangle, that's called right angle. And you take an angle, which is a T. And so this is a triangle, it's a right triangle, and that's important. So the sine of T was defined to be, of course, all of you know that, the opposite over the hypotenuse. The cosine was defined to be the adjacent over the hypotenuse. So that's the right angle definition of the sine and the cosine, which is very useful, of course. But the question is, this definition restricts the angle to an angle less than 90 degrees. Because if I have a right triangle, this angle cannot be above 90. At most it can be have to be strictly less than 90. So this definition does not give a meaning to something like 110 degrees, because I cannot fit 110 in a right triangle. So it's a very restricted definition to a right triangle. So for that, we're going to extend the definition of sine and cosine to any angle. And this is and now we're going to state the definition that we use. So, and this would be called the unit circle definition. So, and that is the definition of sine and cosine we're using, which will basically kind of extend this one to a larger, to more angle. So the unit circle definition of sine and cosine. And cosine. Okay. So what's the unit circle definition? Unit circle definition, of course, as I'm trying to remind you of it, is to follow. So I'll push this up a little bit, and then we start. Okay. We start with the unit circle. Crucial. It means a circle of radius 1. So that's a unit circle. Unit. Sorry, it's not quite a circle. So this should be circle of radius 1. That's the unit circle. Okay. And then we take the following. We take P, a point on the unit circle. On the unit circle. Okay. And let T be the angle. So I'm going to take T. This is T. The angle, very specific, angle between the positive x-axis and OP. So that's my point P, right on the unit circle, and that's the angle T. And now we're going to give the definition of sine and cosine of this angle. Now let's notice my angle is not between 0 and 90. My angle could be anything, because my angle could be here. My angle could be here. So I have angle anything I want. So how are we going to define the sine and cosine? So this is the unit circle definition. Anybody has any memory? Help me out. What's the cosine of T? What's the sine of T? X coordinate, absolutely correct. The cosine of T is the X coordinate of the point P. Crucial. That's the one we use. The sine of T is the Y coordinate of the point P. So this picture should be somehow drilled in our head. If this is T, a point P has two coordinates. So the X and the Y. The X coordinate, in this case, in my picture, that's negative number, that's the cosine. The Y coordinate is this side. So that's the definition of the sine and cosine. Now, before I go any further and start really working with that, because that's really the one that matters, let us notice that if the angle happened to be between 0 and 90, our definition coincides with the definition of the right angle. So let us say my angle happened to be here. Let us say. Okay. So the definition, the unit circle definition tells me the cosine. That's a unit circle, as I repeat, is important. The unit circle definition tells me if you take the X and Y coordinate, This is the cosine right here. And this is the sine. But watch carefully. The cosine, if I take the right angle tells me the cosine is the adjacent over the hypotenuse. But my hypotenuse is 1. It means the cosine is nothing more than this piece right there. The sine of t, the right angle formula tells me the sine is the opposite over the hypotenuse. But if my hypotenuse is 1, my opposite is exactly the y coordinate. So for angle between 0 and 90, our definition definitely coincides with the right angle. So the unit circle is an extension of the right angle for an angle of any, whatever the measure is. Right? So I'm going to ask very simple questions, just really to kind of drill this definition into our head because it's crucial. So my question is the following. Determine the sign, positive or negative, of the following. So determine the sign. And by sign mean positive, negative. The sign means positive, negative of the following. Of course, I don't want you to use the calculator. The calculator will give you everything. That's not my idea here. Okay, so let us, a very simple one. So let me take, for example, sine 3 pi over 4, positive, negative, or what? Sine 3 pi over 4. Is it positive or negative? Quickly, positive. Do you agree with him? Absolutely. I usually don't think very hard. I don't. I go to my unit circle. I draw a 3 pi over 4. Exactly. And I say, okay, what's the sign? The sign is the y coordinate. The y coordinate. So it's absolutely positive. That's why those problems are for. Okay, let us pick up another one. Let me say, for example, sine anything. Just, I mean, I don't know why I'm using the sign. Minus pi over 4. Okay, so let us remember the minus, it means you start and you go counterclockwise, pi over 4. That's minus pi over 4. And I'm taking this angle right here. So positive or negative quickly. Negative. That's the y coordinate. It's right there. That's the sign, which is a negative number. Okay. So two more, and then we proceed to more properties. So let us say I put sine. No, I'm tired of the sign. Let us say the cosine of I don't know, 11 pi over 6. Positive or negative? Okay. 11 pi over 6 is almost how much? Everybody tells me positive, positive. So how much is 11 pi over 6? I'll take my unit circle in here. And 11 pi over 6 is a little bit shy of 2 pi. So that's 11 pi over 6. The cosine is the x coordinate. That's the cosine. Definitely is a positive number. Okay, so once we understand this picture, it's really becoming easy for us to manipulate sine and cosine without a lot of headache. All right, so what I will be doing is just simple examples that, you know, we to help us visualize or understand this definition. Now what I'm going to do is what we call the particular angle that I strongly encourage my students to absolutely memorize because they come up a lot with us. So that's the angle here, that's the sine, and it's the cosine. All right. But that's a particular angle, the 0, and of course the pi over 2, the pi, 3 pi over 2 and 2 pi, and some in between. So the in between are the pi over 4, pi over 6, and of course pi over 3. All right. So, and that's it. That is at the particular angle. You don't need anything else to memorize. So let us start with them. Of course, we should know most of them, or most of you should know them. All right. The first one is 0. No memory for that. What's the sign of 0? Because sometimes if I kind of goof, so I go back to my circle. What's the sign of 0? You're absolutely right. This is 0. It means the angle is 0. That's the point P I'm looking at. The sign is the y-coordinate of that point. So this point is 1, 0. The y-coordinate is 0. The x-coordinate is 1. So you ever forget, you go back to your definition. Let's keep with the simple one because the others you memorize. Pi over 2. Pi over 2, it means I need a pi over 2 angle. I'm right there. That point is 0, 1. So the sine is the y-coordinate. The cosine is the x-coordinate. As simple as that. Pi. Pi, it means I'm right there. Okay, what are these? So that's -1 and 0. So the y-coordinate is 0. The x-coordinate is -1. 3 pi over 2, it means that's 3 pi over 2. That's 3 pi over 2. And this is a 0 and a -1, giving me -1 for the sine 0. And 2 pi, we're back to the same point. So this is 0 and this is 1. Okay, so if you ever forget those, we can go back to the picture. Now the rest we really actually memorize, as you guys know, but it's not like they come out of nowhere. They come from simple trigonometry. So I will show you one of them and the rest I will just give them to you. So for example, it is, let me take the unit circle. I draw it a little bit big here. And let me take pi over 4. So pi over 4 is halfway. That's pi over 4. And that's the unit circle. So what's the sine on cosine pi over 4? It means I'm looking at the x coordinate and the y coordinate. Now, if we use a little bit of basic trigonometry, this triangle here is isosceles. Because if this is pi over 4, it means 45 degrees, and this is be left with pi over 4. So it's an isosceles. What does this mean? It means the sine and the cosine has to be equal to one another. That's already something, okay? And then what's the value? You guys remember the value? Because I want you to memorize basically. What's gonna be the sine and cosine? Anybody remember without a calculator? Square root of 2 over 2. Anybody else besides Elizabeth? All right, so let's see why. As I said, I will show you only why. Because if we use Pythagorean theorem, let me call this one A, and let me call this one A. This is isosceles, it means they are equal. I will get A squared, this side, plus A squared equal to 1. That's really what it is about. It means 2A squared is 1. A squared, which is this side here, which is equal to that, is a half. And we're going to take only the positive because that's what I need. It means A is the square root of a half. So which is 1 over the square root of 2. And if you multiply both the denominator by square root of 2, I will get that. So it's either one you can memorize. All right, so it's really not, it's really geometry to pick up that value. So with this, we do that. That's the square root of 2 over 2. Those are equal, but they generate a isosceles triangle. Now the other two, so that's the other two. Pi over 6 is a half. And this is also done by pure Pythagorean. And the cosine flip them. It gives me the square root here. It gives me the half. Okay, those angles, because they come up a lot, I think we should all memorize them. You should have them under memorizing, period. All right, any questions before we go on? All right, so now let me ask you, let me give you the other trigonometric function that we actually care about. So what other trigonometric function? We know. So other trigonometric function. Please, if I'm moving fast, you let me know because I don't see your faces, as I said several times. So other trigonometric function. Okay, so I will give the definition in terms of the unit circle and in function of other trigonometric functions. So this is my unit circle. And if I have any angle t, this is my angle t. And we know that the sine is the y, and so let me call this is the y, and the cosine is the x. Okay, so what is the tangent? Okay, what's the tangent? Now that's the unit circle definition. The tangent is always, and that's the one we will use the most, is the sine over the cosine. Okay, so we're going to be using that all the time, sine over cosine. And in terms of unit circle, it's the sine, which is the y, over the cosine, which is x. So this is my tangent. Now other trigonometric functions are the cotangent, which is the cosine over the sine, which is the x over y. So these are the ones we use. Then the secant, 1 over cosine. It means 1 over the x coordinate. And immediately we know that sometimes the secant doesn't make sense when the x coordinate is 0. So, and finally the cosecant, which is the 1 over sine. It means the 1 over y. So those are the other trigonometric y. Okay, and I usually, most of the time, I would use their value in terms of sine and cosine more than in terms of the unit circle, because they are more relevant. So now we're gonna do some trig identity. I will not do every trigonometric identity you've seen. I will do very, very few of them, the one that I think we need. If we ever need another trig, I'll remind you of it. So some trigonometric identity. The first one, the most important trigonometric identity is what? Anybody knows which is the most fundamental trigonometric identity? It means relationship between the sine and cosine. What's the most important one? Anybody remember? Always our famous unit circle. Okay, and my angle T right here, my cosine, my sine. Okay, the first, absolutely, John Davis got it. The first important one is that before I write it the way your classmate wrote it, if I look at this right triangle, okay, and this is radius 1. If I take this Pythagorean, so Pythagorean tells me, if I take this side square, it means cosine t square plus sine t squared. It's nothing more than Pythagorean theorem. I get the 1. Okay, so that's Pythagorean theorem. Now, as you know, we have a notation. That's the way your classmate wrote it. The notation for cosine, and now that's a notation that, unfortunately, we use it a lot. A notation. Cosine t squared means, that's a notation now, is cosine square t. That's what the notation is, plus sine square t equal to 1. Okay, so this is nothing more than Pythagorean theorem, no more, no less, which is fully based on the picture. Okay, now there are some other identities that I will ask you the questions and you should be able to answer them quickly. So please, if I move the page before you're done, let me know. Great, now. So that's the first one. Now, other one, I will not state all of them, but I want to ask you the following. What is the relationship between the cosine of an angle, t, and the cosine of minus t? Okay, and I want purely the picture before. So what's the relationship between the cosine and the cosine of minus t? Anybody can write the answer here. The picture attached to it, everything has a picture. Okay, anybody? I don't see answer. This is my t. This is t. Minus t is the one absolutely symmetric to it. That's the minus t. So everything is equal. This and this are equal. So what do you think the relationship? They are equal exactly. It means, or they are equivalent. Your classmate said, in other words, they are equal to one another. Watch the picture. Because of the symmetry, if I take this point and this point, so they are symmetric with respect to the x-axis. It means those 2 points, they have the exact same x coordinate. So from here to here, by definition, that's the cosine of t. That's the definition of cosine. Cosine of minus t, because our definition extends whether the angle is positive, whether the angle is negative, everything. So cosine of this angle is nothing more than the x coordinate. It's exactly the same x coordinate. So that's why the cosine of t, the cosine of minus t are absolutely equal to each other. So this point represents 2 things. This point here is the cosine of t, and it's also the cosine of minus t. So that's the relationship between those 2. All right, let me ask you questions along the same line. So I think all of you expect what I'm going to ask you now, I think. So what's the relationship between the sine of t and the sine of minus t? Again, you use the picture to answer these questions. Okay, so I draw because that's how I think. So I'm gonna draw for you. And okay, so I draw the same thing. So I don't want you to think that I'm changing. That's a t. And the minus t is really almost the same angle. So those are equal. It's from here and this is equal. They are opposite. And so what are the cosine? So those 2 points are symmetric. So the cosine is, the sine is that's the sine of t. And that's right here is the sine of minus t. So if we look at the picture, this point is totally symmetric to that with respect to the x-axis. It means from here to here, the length of those is the same, but they are opposite to each other. So this gives me the relation between them. Okay. Now, what else? Okay, I'll give you 2 more, but I'll give you a minute to answer. What's the relationship between the sine of pi minus t and the sine of t? Sorry, I don't know if it's equal. You have to tell me. And then the last one I will give you is, let us say, the sine of pi plus t, and it's not necessarily equal. You have to tell me what's happening here. And the sine of t. So I'll give you a minute to give me the answer to both of them. Are they equal or opposite? Are they equal or opposite? The first and then the second. Draw a little bit of a small picture so you can visualize the whole thing. And for the first one, what do you think? For the second one, what do you think? We start with that. Luke, tell me opposite. The first one, so let's focus, all of us. I want this. Okay, Luke tells me opposite. Okay, draw the picture. I want you to draw the picture. And Elizabeth, equal. Okay. Okay, draw the picture in front of you. What do you guys say? I have a lot. I have 43 students. I have 2 answers. I need more. Okay, I'm having now another equal. Okay, Nick, all right. So let me see if I agree with everyone. Suppose I take the angle t, that's my t. What's pi minus t? Pi is up to here. I'm gonna take the same angle t from it. So it means, okay, let me draw as this is it. So this one here, this is the pi minus t. Again, the picture. So this is T. So this angle here and this angle here are equal to one another. So the geometry tells me that those 2 points are symmetric with respect to the y-axis. So the sine of T is this point. The sine of pi minus T is exactly the same. So those are equal to one another. Okay, now this one. And you guys will do the cosine. I'm just doing the sine. I leave it to you as a worksheet tomorrow. I want you to do the sine. So again, for the sine, are they opposite or equal? Draw the picture in front of you and try to figure those out. So now we're doing this. Okay, Elizabeth, Wyatt, opposite, absolutely opposite. Absolutely opposite because, again, you draw the picture. So you forget you draw. Somebody tells you that, you remember. This is T. What's T plus pi? You take T and you're adding pi to it. It's absolutely right here. So this is my angle T plus pi. And now that's the sine of T plus pi. And that's the sine of T. So that's the sine of T right here. And right here is the sine of T plus pi. And this angle is T by pure geometry. Okay, so the symmetry would tell me that this is equal to minus. Now to have the same, we can do the same analysis for the cosine, and I think I will put them on a worksheet for you just to make sure you can think this way. All right, so those are the simple property. And now, of course, the most important one, not the most important, but the one that we should know that what we call that the sine is periodic and period 2 pi. It means if I take an angle and I add 2 pi, it's the same thing as the sine of T. So it repeats itself. And that's because, very simply, because of the following. If I take an angle T, and then I take T and I add 2 pi, I go back to the exact same point. So I have the exact same y coordinate. And the same hold for the cosine. So that's the idea that the function is periodic. It means it repeats its value every 2 pi. Okay. So now the last thing that we need to know, which is, of course, I'm reminding you of that. No, before that, I want to do the following problems and I want to do the following questions. And this is addressed to you. I want you to find the following. Find all values of T, such that, I want all values of T such that between 0 and pi over 2, my apology, between 0 and 2 pi, such that, what let us say, such that the cosine of T equal, what do I want? Minus a half. Okay, and I don't want a calculator, I don't want anything. I just really want you to use 2 things, your understanding of the cosine and those particular value that I gave you. It means I want you to use the fact that the cosine of pi over 3 is a half. I want you to use this fact and the definition. And I want all the angle between 0 and 2 pi whose cosine is minus a half. Okay, I give all of you a minute to do it. Okay, anybody have any answer? 2 pi over 3 for pi. Anybody else? Okay, all right. Anybody else? And how we're gonna think about that? How we're gonna think about it? Okay, as I said, I don't memorize. I told you what I want you to use. I want you to use only this one. And then the rest we will actually figure it out. So this is my unit circle. Okay, the cosine of pi over 3 is a half. So this is a half, and this is pi over 3. That's pi over 3. And that's a half. That's the only one I want to use. But now I want those whose angle is minus a half. So minus a half is right here. So I want this one. I want this angle. And another angle have minus a half down here. This one. Okay, and I use only the symmetry in the picture to figure out everything. If this is pi over 3, it means this right here, by the symmetry of the picture, because those 2 points are symmetric, this right here is also pi over 3. So now what are my angles? This black one, this one is pi minus pi over 3. So the first value, which is 3 times pi, which is 2 pi over 3. That's my first angle. My second angle, which is the red one, is actually, if you look at the picture, is the pi plus this little thing, which is pi over 3. So the other one is the pi plus the pi over 3, okay, which will give me 4 pi over 3. All right, so now a little bit, we are able to figure out a lot. So once I know those particular angle, basically, I can start just by looking at the picture, figure out other ones. The last thing we have to look at is the graph, which is all of you, of course, know the graph, but I have to remind you the graph because we should know. So I'll explain one graph and I will just draw the second one. So the graph of sine and cosine and tangent. Y equal tangent. Okay, so I start with one, as I said, and then the second one, I will just remind you how it looks. So y equals sine. Let us remember first the definition that I will never back off from. So the definition of the sine is you start from here, and if you take an angle t, the sine is nothing more than the y coordinate. Okay, that's really our definition. Now, what do I mean by the graph? In this thing, we change. On the y-axis, sorry, on the horizontal axis, we put the angle in radian. Okay, and so now I'm thinking of this as a function that to every angle t, it assigns the sine of it. So on the right here, we put in the value that we assign to the angle. Okay, so now it's a function for me. Is that an input with the angle in radian, the output is the sine. And let us graph this. At 0, the sine of 0 is 0. So we start right there. Okay, and then at pi over 2, those are the ones we know. At pi over 2, so this is my pi over 2 right here. My sine is 1, so 1. And what's happening in between? As my angle increases, so my angle increases in value, the sine, which is the y coordinate, is actually increasing. So as we realize, it increased up to 1. So my sine is really increasing all the way up to 1. So as the angle goes from 0 to pi over 2, my sine is actually increasing. Now after that, the sine, which is the y coordinate, is actually start losing value. It's positive, but start losing value. Start losing value up to pi. So when it hits pi, it starts losing value, but between pi over 2, it's really actually decreasing in value. And then after that, what is going to do? At 3 pi over 2, so I need to make this tiny bit bigger here. At 3 pi over 2, right here, the sign is -1, but in between, the sign is negative. And negative is the y coordinate. It's getting more and more negative. So it's right here is -1, getting more and more negative because the value are getting more. So this is really verbatim how the graph is moving. Then after that, so this here I am at 3 pi over 2. And after that, it's pushing up. It's still negative, but it's getting less and less negative, less and less negative, heading toward 0. Now, after that, as we all know, and as we mentioned, the sign repeats its value. It means if I take an angle t here, and I take t and I add 2 pi, I repeat my value for the sign. And that's why it starts becoming periodic. So it keeps going from both sides. Okay, so that's the graph of our sign that we have absolute memory. Another point I like to emphasize. Suppose this is t, that's the sign of t. When I take minus t, we know before the minus t should be right there. It's just the opposite. So sign of t here, and this is the sign of minus t, which is minus the sign of t. So that's really how the graph of sign, it's coming from here. It's not coming out of nowhere. This definition leads us to the exact this graph. Now the graph of cosine, I guess by now I will just fly through that. So the graph of cosine, it's the same, not the same, but it's actually kind of, so basically it's the same but shifted. So the graph of cosine, again, using the definition of the unit circle, we can sketch the graph. That's where the graph is coming from. And the main difference is that the cosine at 0, it's a 1. So it starts from here, from the top, and then after that, things repeat itself. Pi over 2, pi, 3 pi over 2, 2 pi. Then it starts going down. It's going to be positive, getting less positive. It's the x coordinate. So if the angle moves, the x coordinate is actually it's still positive, but it's heading toward a 0. And then it will, that's at pi over 2. And then at pi, when I am right here, it takes its value -1. It goes up. Okay. That's one period. After that, they start repeating, the values start repeating themselves. Right? So this is the cosine. And from here, it's the same. The graph just repeats itself. And as we realize, the symmetry, there is a total symmetry at t, and at minus t, the value of the cosine is exactly the same. Now the other graph is the tangent, and we talked a little bit about this one. So y equal tangent, or f of t equal tangent t, it doesn't really matter. All right. So let us remember the tangent is by definition the sine over the cosine. It's the sine over the cosine. And whenever there is, you have a function and there is a denominator, the domain, I mean, immediately will start, come to our mind. So what's the domain of here? It means which values I cannot plug them for t in the tangent function. Okay, so let's see what's the domain. Everything that makes the cosine 0 has to be out. So cosine t equal to 0 for which value of t? Okay, that's my graph. When is the cosine 0? Pi over 2. 3 pi over 2. So that's pi over 2. 3 pi over 2. This is why it is 0. Please, I want you, all of you, to totally memorize those graphs. And then pi over 2, you add 2 pi. 3 pi over 2, you add 2 pi. Or you take away 2 pi. So in general, it's going to be plus or minus pi over 2 plus or minus 3 pi over 2. The tangent doesn't make sense here. Plus or minus 5 pi over 2. All the odd power, all the odd 7 pi over 2, and so on and so forth. So that's where the tangent really totally doesn't make sense. So when we're graphing the tangent, we have issues at pi over 2. We have issues at minus pi over 2. There is no output there. We have issues at 3 pi over 2. And we have issues at minus 3 pi over 2. So right here, the graph, we have those, because the graph, the function is absolutely, totally not defined, totally. And so also, it will not be defined at 3 pi over 2. That's how the graph is going to have different branches, because it doesn't really make sense here. And now how it looks like. I'll just draw it. Looks like this. At 0, tangent 0 is the sine over the cosine. Sine 0 is 0 over 1, it's 0. And the way it works, this based on the definition again, is actually, it's going to go like that. It's almost, that's an asymptote. And this one, between minus pi over 2 pi over 2. And after that, let me remind you something, and I will stop. Tangent of t over t plus pi, and tangent t. Are those equal to each other? It means when I take an angle, any angle, t, and I add 2 pi to it, will the value repeat of the tangent? And the answer is yes, because what's the tangent t plus pi? It's the sine of t plus pi over the cosine of t plus pi. So in terms of the unit circle, what's really happening? This is my angle t, and let's see, call this point xy. T plus pi is right here. So if this is x and y, this is minus x minus y, just by symmetry. Total symmetry. So if the tangent of p is y over x, which is the sine of t plus pi, which is the y over x, tangent t plus pi, it's the minus y over the minus x. The tangent t is the y over x, but this is the same thing as y over x. Okay, so the tangent of t is y over x. Tangent t plus pi is minus y over minus x. Minus over minus give me the plus, means those two angles have exactly the same tangent, which makes the tangent periodic, but it repeats itself every pi. It doesn't repeat itself every 2 pi. So from here to here, basically I have a pi. Okay, and this is really coming again from the definition. This is the angle t, that's y over x, t plus pi minus y over minus x, but those are exactly the same number. All right, with this, I basically finish our review for the sine and cosine. And for tomorrow, it's again not my lab, it's also a worksheet that I will put on Brightspace in a minute. And please, you do it. And as you realize, the worksheet I give you, they are not for grade, you don't have to hand them in, but I definitely quiz you over them because I think they are important for you. Okay, so any questions before we let go? So please do the worksheet for tomorrow and ask questions as usual. The last thing is, again, I remind you, read the feedback I give you on the quizzes so you don't repeat your mistake again. Anything before I go for my office hours? Okay, bye-bye for now. See you tomorrow, guys.